Welcome to this session. In today's session, I'm going to discuss about certain problems in atomic structure. We'll see some multiple choice questions and let us see how to solve them. So I will be first displaying the question on your screen, and just read that question, and once you read that question, we'll discuss the solution of it. So let us discuss the first question, which will display on your screen. In this question, he's talking about, there is a transition of electron from n is equal to 2 to n is equal to 1. Okay, and he's asking you what is the shortest wavelength that has been produced. Okay, so that means n is equal to 1 is the ground state. Okay, ground state, and n is equal to 2 is the first excited state. So when electron is jumping from n is equal to 2 to n is equal to 1. Alright, that is the situation given. And three different atoms are given: hydrogen, deuterium, and helium, singly ionized helium and doubly ionized helium. Okay, now in this situation, actually what happens, what is deuterium? Deuterium is 1H2, and lithium Z value is 3. So if you carefully observe that formula for calculation of lambda, that is given by 1 by lambda is equal to r into z square by n square. Okay, so in this situation, actually this 1 by lambda is actually proportional to z. That means if the z value is increasing, lambda value is decreasing. Okay, so this lambda value is actually dependent upon the atomic number, and the atomic number is more for lithium here. So the option will be between C and D. Now D is doubly ionized. Okay, so one is singly ionized and one is doubly ionized. So in this situation, so which one we have to select? So we have to select actually the doubly ionized lithium. Okay, because it is coming from higher excitation state to the lower excitation state. So right answer would be option 4. Okay, so let us see the next question. If you see the next question, the question is on X-ray beam, which is been coming from an X-ray tube. So which options are correct? So first of all, you need to understand that X-rays which are produced, their wavelengths are in the range of 0.01 to 10 angstroms. Okay, these wavelengths are very, very small, so their penetrating power is very high. They can penetrate through human cells, body cells. So if you look at the first option, you can just go back and see. If you look at the first option, that is monochromatic. Monochromatic means something which has a single color. So but this doesn't fall under that category. So the first option is wrong. Coming to the second option, if you draw a graph between applied voltage and intensity, the graph will look something like this. It will look like this. So what is this called? This is called cutoff wavelength. And there is a formula to calculate this also, cutoff wavelength. Now basically what happens, this part is the continuous spectrum. Okay, and this part is the characteristic spectrum. This is the main concept behind characteristic spectrum. This is the concept behind X-rays. So here there will be a spike whenever this electron, electron which is coming from outside, it is hitting a particular electron and knocking it off. So electrons from the higher shell will replace them. Okay, so in this process actually some energy will be released. So this spike represents that characteristic spectra actually. So it can belong to K alpha or K beta or K gamma series, or it can belong to L series or M series, depending upon which electron is replacing. Suppose this electron is replacing this one. See, this is K, this is L, this is M. Suppose M is replacing L, then it makes L series line. L is replacing K or M is replacing K, it forms a K series line. So the main point is here, so minimum wavelength that won't be a zero value, because how do you find minimum cutoff length? Means lambda minimum is equal to 12,400 divided by voltage. This value is not equal to 0. If you carefully look at the option, the third option, it has all the wavelengths which are larger than a specific value, specific small value. It has all the values. It can go up to right up to infinity. Okay. In the second option, it is saying that the wavelengths are smaller than a certain maximum wavelength. Okay. And the third option says that having all the values which are larger than a certain minimum value. See, all the wavelengths are larger than this minimum value. So second option is wrong, third option is correct. If you look at the fourth option, it says that wavelengths lying between minimum and maximum wavelength. So there is no maximum wavelength as such. Minimum is defined, maximum can be anything, it can be infinity also. So option C should be the right answer. Now let us move to the next question. So I will flash it, just go through that question. Now in this question, he is talking about K alpha X-ray emission. Okay, now what is K alpha? Just now, like I told you, this is the nucleus, this is the K shell, this is the L shell, and let us say this is the M shell. And this fast moving electron, it is knocking off one electron from the K shell. So maybe L can replace it, or maybe M can replace it. So if L is replacing it, we will call it as K alpha. If M is replacing K, we will call it as K beta. Basically these form the lines for K series. Okay, so in this question he says that the X-ray emission of a tungsten is chosen, that is the target metal, and whatever that when it is knocked off, somebody is replacing it. Let us say element from the shell of L. So in this process actually some radiation will be emitted. So this radiation lambda value he has given as 0.02 nanometer. Okay, 0.02 nanometer. So we have to find out what is the associated energy with it. Associated energy would be E is equal to 12,400 divided by lambda. Lambda value should be in angstroms. We know that 1 nanometer is equal to 10 angstroms. That means 0.02 nanometer is equal to 0.2 angstroms. Okay, so this energy becomes 12,400 by 0.2. If you simplify, you'll get approximately 62,000 electron volts, which is 62 kilo electron volts. So actually none of the options are matching. This is the correct answer. Okay, so let us move on to the next question. So next question, as per the Bohr model, the minimum energy required to remove an electron from the ground state of doubly ionized lithium atom. So what is the meaning of removing? So this is the nucleus, this is the electron in the ground state, and these are higher orbits. Okay, so this electron has been removed and has been knocked out. Okay, so here electron is not replaced, it is been removed from the ground state. So here we can directly apply the Bohr formula, En is equal to minus 13.6 Z square by N square. Okay, so this is he's talking in the case of lithium. So for lithium it is minus 13.6 into Z value is 3 and ground state means 1 square. So if you simplify, you'll get 122.4 electron volts. Option 4 is the correct one.